Assalamu alaikum students. This is your seventh lecture on water supply and sanitary engineering. In this lecture, you will study about the factors affecting rate of demand and the variation in rate of demand. Now, starting with the factors affecting rate of demand. First is the climatic condition. In hot climate, that is summer season, the water required will be more, and in a winter season, less water would be required by the people. So the rate of demand for summer would be obviously more than that for winter. Next is the cost of water. If the water is supplied to consumers at high cost, they may use less quantity of water. So the rate of demand decreases as the cost of water increases. Then the economic status of consumers. Rich and upper class people generally consume more water as their standard of living is better. So the rate of demand increases with increase in economic status of people. Then the number of industries. If more industries are present in a town or a city, then obviously the more water would be consumed by that town. Now the method of charging. It means whether the system of charging is metered or unmetered. The people with a metered system of water supply will use less quantity of water as compared to the unmetered water supply system. Now, the quality of water. If a good quality of water is supplied, then people would like to use more and more water as they would find it safe to use. The size of a town or city, as the size of town increases, then the water demand will also increase as the population will increase. Now, coming on to the variation in rate of water demand. The variation means change. So here you have to study how the rate of demand changes with seasons, months, days, and hours of a day. The types of variation can be seasonal or monthly variation, daily variation, hourly variation. Now starting with the monthly variation, or we can say seasonal variation. It's the change in demand of water from season to season. Like if you find out the average rate of demand for a year, in summer the demand will be 30 to 40% above that average, and in winter it will be 20% below average. As in summer, more water is required for drinking, bathing, air conditioning, etc. Now, the daily variation. The rate of demand changes from day to day. Like you may use more water on holidays, festival days, dust storm days to clean the houses, and less water may be used during the rainy day. Now, moving on to the hourly variation of demand. The graph shows the variation in consumption of water starting from 12 midnight, that is marked as 0 on abscissa. On the abscissa, you have hours of the day starting from 0 to 24 hours, and on ordinate, you have consumption in million liters per day. Then at 4 a.m., the use of water starts increasing. You can see it increases up to 8 or we can say 10 a.m., where the peak use of water or peak demand occurs. Again, it decreases as people may be going to offices or workplaces. Then at 4 p.m., it starts increasing up to 8 p.m., then again decreases. The demand of water for the whole day is given in the graph. and the average rate is also shown. Now the maximum demands of water, starting with the maximum daily demand of water. It's the maximum rate of demand on the day of maximum use of water. It's equal to 180% of the annual average daily demand. Now what is annual average daily demand? It is the average daily demand for taken for a year, say. So the maximum daily demand it's equal to 180 by 100 into Q, or is equal to 1.8 Q, where Q is the annual average daily demand. Now the maximum hourly demand of water. The average hourly demand on the day of maximum use is equal to maximum daily demand divided by 24. And now what is the maximum daily demand? As you know, it's 1.8 Q. It is maximum hourly demand. It's 150% of average hourly demand. That is 150 by 100 into 1.8 Q divided by 24. It comes out to be equal to 2.7 into Q by 24. Now what is Q by 24? It's annual average hourly demand. Now how can we calculate the maximum demands of water? May it be monthly demand, weekly, hourly, daily demand. For this we use Goodrich's formula, that is P is equal to 180 into T raised power minus 0.10, where P it's the percentage of annual average demand of water. It can be monthly demand, weekly, daily, hourly, for which we are calculating. T it is the time in days and it varies from 1 by 24 to 365. Like for one day we can take T equal to 1, for 1 hour we can take T equal to 1 by 24, for a year it's equal to 365. Now first we will calculate the maximum hourly demand using Goodrich's formula. For maximum hourly demand, T would be equal to 1 by 24. As there are 24 hours in one day, therefore P it's equal to 180 into 1 by 24 raised to power minus 0.10. By substituting 1 by 24 in place of T. So P is equal to 247%. That is maximum hourly demand divided by average annual hourly demand. It's equal to 2.47. That is maximum hourly demand is equal to 2.47 times annual average hourly demand. Now for maximum daily demand, how to calculate maximum daily demand? Take T is equal to 1 day. Therefore P it would be equal to 180 into 1 raised to power minus 0.10. So P is equal to 180%. What is maximum daily demand? It would come to be equal to 1.8 times annual average daily demand. Similarly, you have to find out the maximum weekly demand and maximum monthly demand. You will find out these demands by yourself. Now, what is the coincident draft or coincident demand of water? During fire, there is certain increase in demand of water. So, for firefighting, besides the usual demand of water. So, provision should be made for firefighting to meet the fire demand. So, the maximum demand is added to fire demand. The coincident draft is the maximum demand during firefighting. Or in other words, we can say the coincident draft is the fire demand plus maximum daily demand of water. This was the end of this lecture. In the next lecture, we will study about the population forecasting methods.